Hello friends, I am Sanchit Mehra and I'm back again with another video on unordered set. And in my previous videos, you have already learned about sets in C++, which uses a balanced binary search data structure internally and which makes the normal operations on it like searching, insertion, deletion into a logarithmic complexity. Since the internal implementation of sets in C++ is binary trees. But here we would be learning about unordered set here. So the properties of unordered set you should be aware of. So being a set, it contains a unique elements. Okay, so whether you are working on a simple set which is an ordered one, and this is the whether in unordered set, both contains unique elements because both are set, and set properties are that they will contain only unique elements. Okay, now the second difference is that elements are not in any order. Okay, so we cannot maintain any order, but in a set, which is the ordered one which we have learned in our previous video, they maintain a certain order. Why? Because the internal data structure which is being implemented by a set in C++ is a balanced binary tree. Okay, so balanced binary tree provides an ordering to all the elements that are there. But here in unordered set, we are using the hash tables. And in the hash tables, we are not storing any unique information about order. Okay. So for example, if you find a case where you want to store unique elements plus you want to maintain an ordering, I would suggest, or basically what is suggested is to maintain a doubly linked list as well to maintain the ordering or to get the ordering in that case. But unordered set alone will not give you any order because the underlying data structure is hash table. Okay. Now the third point is automatically what I have said is that since it uses an hash table, there has to be a keys for hashable keys basically, and those keys cannot be changed. Okay, why? Because you are inserting those keys, and those keys will find a value in a bucket in a hash table, a place in a hash table. So if that could be changed, then it doesn't make any sense to insert that key into a table. Why? Because it occupies certain value, it occupies certain place in hash table, a certain bucket. Okay, and that has to be constant throughout. Okay, yeah. So now the fourth point is it is associative container. That means you just with a key you are able to get the key or associated value, or in an ordered set it's a key itself because it's the only thing that you insert and that you only get. Okay, so it's not indexed just like a vector. These are not indexed and these are not ordered. Okay, so elements are stored in a buckets in hash table as I already told you. Now the fifth point is amortized time complexity of basic operations is O of 1. Why? Because of course the underlying data structures that is storing the elements in unordered set is hash tables. Okay, so there are certain concepts of collisions that you can study, how you can optimize your hash functions so that there are minimum number of collisions, and your hash table is optimized for O of 1 complexity for such simple operations like searching, insertion, and deletion. And of course I use the keyword amortized, that means an average time complexity. And the reason that I am saying is that because once your elements or your keys goes on increasing, the hash table goes on increasing as well, because it has to keep all the elements that you are inserting in an unordered set in the hash table without avoiding too much of collisions. Okay, so that it can give you an optimal time complexity. So it's an amortized time complexity which is O of 1. And the last point, which is the most important, is the keys should be hashable. Okay, so what do I mean by that? That every element has a function, should have a function which can generate a hash code for that element, because with that hash code the elements would get a place into the hash table. So that hash code defines the place into the hash table. So every element that you gonna insert in your unordered set would certainly have to have a hash function to generate a hash code which will find a place in a hash table for that element. I hope that is clear. Okay, so for example, for the strings and integers, the hash functions are there, but for an objects, for a user defined objects, okay, for a user defined constant objects, you need to define how would you provide a hash function for unordered set to be hashable. But that's a advanced, little bit advanced concept that I will be taking on in other lecture. Okay, but today there will be a simple exercise of familiarizing you with unordered sets, the basics concepts. Okay, so these are basically the properties. I hope this is clear to all, so that I can begin the implementation. I can begin about the how to reuse the unordered set in your daily programming exercises and your scenarios in which you would be needing a unique elements. Okay, so first of all, you need to include this header file unordered underscore set, which contains all the declarations. Okay, so now we have a main function here, and let me first define an unordered set here, or declare it. So here you will give about the class type. I mean, it's a templatized type, and you need to define the type also, whether you will be having an integer or a string or a float or any kind of object. Okay, so for simple purposes, I would be having an int type. Okay, and the first way I can initialize another set in C++ I see is initializer list. Okay, so I give it a name, and I have an initializer list here, 1 3 5 7 8 and 9, and then I can have again 5 3 1, because no one is stopping me for inserting the elements which are duplicating. Okay, I can insert it, but the thing is that it would not get duplicated inside when the element is, when you're inserting it, it will not include that into its container. Okay, so this is what I've initialized it. I will write a common print function for us to pop into the unordered set what all elements are there. So a normal print my set, or simple print set. Here I can have std unordered set, type is t. I could take it as a reference, and here my set here, and here I could take auto id. Here would be my set dot begin. So begin is a method which gives me the first iterator to the first element. Okay, and here I would have a condition for loop to end. Okay, and here I would be incrementing my iterator. Okay, and here I would be printing, I would be dereferencing this iterator, and here it is. Here I can have one more debug print here. Contents of my sets are here, and here I can have like this. So this is the generic function which I have written here, and this will print the contents of my set. That's all the elements are there. So I'll explain you. So these are one of the methods, which is begin, which is give you the iterator that is pointing to the beginning of the element, and end is again a method which gives you an iterator that is kind of an invalid iterator, and which is one past the last element of my sets. Okay, so if you are just incrementing the iterator, and if after everything you have done, after every element you have covered, at the last it gives an iterator which is equal to end, and so I want my for loop to iterate till it does not become equal to my set dot end. The iterator value does not become equal to my set till the time it will iterate, and it will give you all the elements. And after the iterator becomes equal to the iterator which is written by AND, it will come out of the for loop and your iteration ends. Okay, so here I will write print set, I will pass my set here. Okay, so let me run this short example here. Build succeeded, and here the contents of my set are 975831. So you see, my dear friends, that I inserted in this order my initializer list in this order, but this order is not maintained here. Okay, and the duplicate elements are out. Okay, so you can use unordered set in programming questions, in the programming exercises in which you want unique elements, in which you want to find the number of duplicate elements, or you want to find the unique elements in your array. So you can take an help of this data structure. Okay, so once you insert it, it becomes it only takes the unique elements. Okay, yeah. So next is after initializing it, you can initialize it with multiple ways also. For example, you have a vector here, let's say of integer, and you initialize it with, let's say, 10, 20, 30. Okay, for this let me also include the header file of vector. Yeah, so here, yeah, so I have a vector this, and I want to insert all these elements into my set. Then I can use this method insert. I can use this, and I can pass vec.begin. This will give me the pointer, that will give me an iterator that will point to 10 element, the first element, and vec.end. So of course this is one past the boundary of the last element. Okay, so this is the procedure, and let's say now I'm inserting this whole vector into my set. So let me also include one more 30 here. Okay, so you will see that only 130 is being inserted here. Yeah, so you see 10 is there, 20 is there, 30 is only one time is here. Okay, but again, the ordering is not what we see, that ordering is not maintained here. Okay, now in this case also there could be an array also. So let's say you have an array here, arr equals 2, and here it is let's say 100, 200, 300. Okay, and again I can use it, my set dot insert arr. So this arr would automatically get resolved into the pointer which points to the first element, and then we have to take a pointer which points to the past beyond this element. Okay, so it would be arr plus 3. Okay, so let me see how this is inserted now in my set here. Yeah, so you see 100, 200 and 300 are all inserted. Okay, so these are the way you can have an iterator for begin to end for any containers. Okay, iterable containers, and you could insert it into my set, and then you can print it as well. Okay, now there is let's say you want to find some element, whether it exists in that unordered set or not. So we have a function here, my set dot find here, in which you have to, let's say you want to find whether 300 exists or not. Okay, yeah, so you have to find, and what it returns, it returns an iterator. If the element is there, then it will return an iterator which points to element 300 here, and if the element is not there, it will return an iterator which is invalid. Okay, which is an iterator returned by the end method. So I can use an if condition here. If not equal to my set dot end, then I can write that element is there in my set, and if that is not the condition, I can write element is not there in my set. Okay, so let me see. Yeah, so we can see element is there in my set because 300 is there in my set, and it returns an iterator that is pointing to that element 300 inside the set. Okay, but if I search for 3000, then this element is not there in my set, and it will return an iterator that would be equal to the iterator returned by the end method of my set, and so this condition would not be true, and it will say that element is not there in my set. Okay, so let me run it. So you see that element is not there in my set is printed since 3000 is not there, and so there is no iterator that is pointing to the element 3000, and hence this condition becomes false. Okay, and so this is printed. So there is this method to find some element here. Okay, now we have discussed about inserting, we have discussed about how you can search thing, you can find it. Okay, and now we'll learn how you could erase something from unordered set. Okay, so now we'll learn about erase here, erase elements in unordered set. Okay, so now again, my dear friends, we can see there is an erase function here. Okay, so my set dot erase. Okay, so in erase here, see, so there are three methods you can see here. One is the iterator. You can also pass an iterator that for the element that you want to delete it. Okay, if you do not have an element, then you can pass a key also, and then you can pass the range also in the last method. Okay, so for example, let me see, like if I want to delete let's say 300. Okay, 300, not 3000, sorry, but I want to delete 300. Okay, so I can do it like my set dot here erase function here, and use 300. Okay, and then I would print my set to see what is the result now. So you see that 300 is gone now. Okay, but what happens if you want to delete an element which does not exist in my set? So we can see this 3 lakh, this number is not existing in my set, but still I am calling this erase method here on my set. Okay, so let's see what happens. Yeah, so you see that nothing happens, it doesn't crash, it doesn't throw any exception, but it doesn't do anything here. Okay, but yes, if you are erasing it, it returns whether it erased it, whether it was successful in erasing it, or to be more technical, it returns the number of elements that has been erased. So since my set would be having a unique element, so if it erases, it will return 1. If it doesn't erase anything, it will return 0. Okay, so I can have here result equal to this, and here I can see if result equals to 0, that means element is not erased since element is not there. Okay, else if the result would be 1, because had it been the element there in my set, it would be only one element, so only one element would be erased here. So is erased here. So if I run it, so yeah, it will now print it that element is not erased because the element is not there. Okay, now if I do it as 300, it would surely delete it because the element is deleted, and the result would be 1 here. Okay, so here I am running it, and here we can see, yes, element is erased, and you can see the 300 is also gone. Okay, Now you can, this is the directly the key you can pass, but you can also pass the iterator as well. Okay, so it's giving a warning because here the it should be size underscore t, which is again a unsigned integer. So it expects me to put it like this. Let me see. So it should be gone. So let me again, yeah, so the warning is also gone because the type of the data type that it returns is of unsigned integer. Okay, now here this is you can see it's returning a, we are deleting a number here. Now I would delete the element which is pointed to by an iterators. Okay, so let's say I have a problem here which is delete, or we have erase all the elements in unordered set which are, let's say, even. Okay, so what I will do is that I would traverse it and I would be also deleting the elements. Okay, so this is not possible with certain kind of containers, but with unordered set there is one technique by which it is possible to iterate as well as to delete the element. Okay, so it is, I've already told you that my set arrays have one overload, which is this const iterator. So I can pass an iterator and I can tell my set container to delete that element which is pointed to by this iterator. Okay, so I will take the help of this one overload of arrays. Okay, so let me again iterate it. A simple method to get the begin iterator, check, sorry, to check whether my iterator is not invalid, to continue processing and incrementing the iterator here. Okay, now what I would be checking is if, okay, so if let's say iterator, I delete all the elements, so mod 2 equals to 0, I would call my set dot erase, and I'll use an iterator here, not the value, so I'll pass the iterator here. Now the problem is that once you are using an erase with an iterator, what it will return is the iterator which is passed beyond the element that you have deleted. For example, let's say this example here, this one. So let's say if I am deleting 30 here, okay, then it will return the erase function which will be eliminating this 30 number from the my set. It will also return me an iterator which is following the number that you have deleted. So the iterator that it will return me is, I will update my iterator here. Okay, and I would not be incrementing it here because I wanted to update it also. I would update it in else condition like this. Okay, why? So this is a very beautiful example because the iterator you have deleted. Okay, for example,